No, when you think about industrial safety, you probably think hard hats. But it's so much more than that. It's about making sure these absolutely massive structures don't just fall over when the ground starts shaking. This is the brief on IS 1893 Part 4. Click on the link below to watch the full video. Now, we're not talking about your average house here. This is the seismic playbook for the real giants. Think refineries, huge silos, places where a collapse is a way bigger deal than just a pile of rubble. Okay, so here's what you really need to know. First, the standard sorts all structures into 4 risk categories, and it's all about the consequences of failure, right? So, Category 1, that's the supercritical stuff. We're talking hazardous plants where a failure could be an absolute disaster. Naturally, the design rules for those are way stricter than for, say, a simple shed that would be in Category 4. Second, there's this really smart dual design philosophy. It basically plans for 2 different levels of earthquake. For a moderate quake, that's the design basis earthquake, or DBE, the structure might get some cracks, but it's got to stay operational. But for a massive one, the maximum considered earthquake, well, the building can take some serious damage, but the one thing it absolutely cannot do is collapse. It has to stay standing. And finally, the standard gets really specific about certain shapes. I'm talking about those tall, skinny, stack-like structures, like chimneys and towers. They get their own special rules for vibration and have super strict limits on how much they're allowed to sway. It's all about making sure they don't just snap. So when you boil it all down, IS 1893 Part 4 is a risk-based framework. It's all about ensuring our most critical infrastructure can take a punch from an earthquake and survive. Like, share, subscribe to ISO Automation Lab. See you in the next video.